Our guest today is Ivan Ravlich. He is founder and CEO of Hypernet. And of course, my name is Mahesh Sashital. I'm the co-founder of Smartereum. Hi, Ivan. Thanks for joining and welcome to Smartereum TV. Could you tell us a little bit about yourself?
Yeah, sure. Hey, and thanks for having me here. This has been pretty great.
Absolutely.
Yeah, I guess maybe a little bit about myself. I was born in Los Angeles, and I ended up moving to New Zealand when I was 13. My dad's originally from there, and I was in New Zealand where I discovered my love for engineering. My father was a mechanic, but I wanted to get into biofuels, and that's kind of what got me into engineering itself. Then my career kind of unfolded from there. From finding a new way to produce titanium, to ceramic body armors, to aerospace engineering, and just across that whole field, computing was just a thing that was underneath the layer of everything.
Okay. You kind of briefly mentioned engineering, but you didn't actually talk about you're a legit rocket scientist with a master's in aeronautics and aerospace from Stanford, no less, and a PhD on the way. Well,
I ended up, my PhD's on hold for the moment. Hypernet was calling, and it was time
of
to.
course, of course. So, what launched you into blockchain technology?
Yeah, so actually, it was Hypernet. Back before it even had a name, we'd been thinking about how we could do like large-scale parallel computing on users' devices, from laptops, desktops, smartphones, and we realized in the early days that the biggest problem to solve was how do you coordinate the compute of everything? How do you get all the computers to talk to each other and actually do useful computations? And so that's what we had focused a lot of our time on until once we had solved that problem and it's been time to start actually developing the network, there came a point where we needed to figure out a way to actually schedule a compute job. How do you allocate resources on a network, and how do you actually have different compute buyers like to have priority and allocation on a network and do that in a decentralized way? And so that's what kind of led us into blockchain, was a technological need from a scheduling point of view for the core technology to actually bring this product from this more theoretical curiosity into something that could be used quite widely in the industry.
Using the technology that you've got, what problem are you trying to solve? What's like the business case for this? Why does the world need a hypernet?
So really, it comes down to data, right? Data is king, but data is only king if you can actually get insight from that data.
Right.
How exactly do you go from your user data or your company data to insights out of it, so you can then better serve your customers and better serve your clients and everything like that? And so what you end up needing is compute to actually extract those insights. And so as we are moving into this decentralized future where you have the need for data privacy from users, where you have more control in the hands of the people on your networks, as well as these evolution of these peer-to-peer technologies, you end up with a problem. And that problem is, how do you gain insights and intelligence from your data when it's all decentralized? Right. Because right now, today, the reason why Google and Facebook are quite large giants is because they're able to aggregate all of that data and then do all their compute analytics on top of it to better serve you. And when we move into this decentralized world, how are you going to actually do that if you cannot compute on decentralized data in a meaningful way?
Okay. Is there like another application that you plan on building on top of this data manipulation engine?
Yeah, so if you think of a simple use case, let's say we have maybe it's a food delivery application where you have all of your browsing in this application, and you're saying on lunch on Tuesdays I would like to order tacos, for dinner on Saturdays I'd like to order from my favorite Korean restaurant. You're building up this history of how you're using that application. Right? Today, that food application will need to vacuum all that data that you're interacting with it up and put it in a central repository. And they do this because they can better recommend you. Hey, you like this food, maybe you like this stuff, and
Yes.
they don't use just your data. They will use the data of all of your friends and everyone else on the network to kind of build up these recommendations for you as a user.
Mm-hmm.
So one of my co-founders, Daniel, he was just in Europe for a conference, and they ran into some issues with, or some interesting things with GDPR, the Data Privacy Act over there.
Yes, absolutely.
And if you want to keep user data private, if you want to keep user data on devices without actually being able to identify people, how can you do recommendation? How can you do this kind of more targeted service for your users if you cannot aggregate that data somewhere and compute on top of it? So that would be one application where it's almost privacy enabling, because really today you could argue that privacy, you don't have any privacy, whether it's whether they're doing some funky stuff to your data or not. They're still absorbing it all into a central repository. And so can you make user data private? And on these P2P decentralized applications, you can, but then you lose the ability to compute on that data and actually have the full-blown service that a centralized application would have. And so what we're trying to do is saying, hey, we can actually provide that kind of level of analytics that you would have in the cloud. We can do that on device across your entire user's database itself without ever needing to compromise user data, and also leave it there. Just leave it where it was generated.
Huh, okay. Obviously, this is going to be running on multiple devices, right? What kind of devices are these? Is Hypernet going to be running on? Is it just computers and mobile phones, or are you looking at other? Because obviously, there's computational power in everything from cars to you name it. It's there, right? So.
Yeah, so when you just look at where data is actually generated, because we want to compute where data is generated, right? Data is generated on smartphones, generated on laptops, it's generated in those cars, it's generated at traffic lights if it's a smart city type application. So, when you really look at how we've gone about designing the system, we want it to be as lightweight as possible so it can run on things like smartphones, that it can run on small microcomputers in the middle of cities. So really anything that has a networking card, ability to talk over the internet, and a CPU or GPU can be leveraged on the network in the future. That's our vision.
Okay. So Ivan, tell us the Hypernet origin story. How did you guys start?
Yeah, so this is a good one. So a bit of more background about myself. When I was at Stanford, my work was in plasma rockets, actually for a bit there for my master's. And it was really like, you have these large, I would need to do, and my lab would need to do a lot of these as well, a lot of very large plasma simulations where you're simulating in a computer like all the plasma particles and how they interact with each other. And I've had colleagues that have launched jobs that require 100,000 computers just to do like these simulations we were working on. And so when you're trying to leverage that much computing power, you start to have to fight with other researchers for time on like government machines, or one of my buddies recently was talking to me he's like, Ivan, I'm now seeing your pain because I need to leverage a bunch of GPUs in Amazon, and I have to wait a couple weeks and they charge me a lot of money. Why can't that's pretty crazy that you have that problem. But when I was looking at it from my point of view, and also my co-founder Todd, who his whole research was in like data-driven numerical methods, we were looking around Stanford's campus and we realized, wow, there's quite a lot of computers out there. Like, why can't we tap into these and like do something that we would like to do with them? And so what turns out to be that it's not a new idea. SETI at Home, which is one of the very first like public resource computing projects back in the 90s, we're leveraging people's computers at home to look for aliens. And the need to leverage public resources for computing was a thing that people have been working on for decades. And the problems that you could solve on those were quite limited. And the reason for that is, under the hood, if you want to do anything that requires coordination between all the computers, you need to leverage what's known as a parallel programming model. And the moment you move down to a network of laptops, desktops, smartphones, problems in the network arise that you never would see in a data center, where some devices are slower than others. Sometimes the networks drop out. Maybe a device will come in and out of the network. How do you handle that? And the parallel programming models that are really great for the cloud are broken when the moment you move them down to this decentralized network. And so we tried running some very large simulations. Of course, they fell apart. It was too slow. And realized that we need to solve that parallel programming model issue itself. And how we ended up doing that was because we were aerospace engineers, we love drones, we love the UAV stuff. And so we were in this class on distributed control of robots. Like, how do you control big swarms of robots? In this case, it was a swarm of drones. And, you can find videos of this stuff where you have like a single joystick and you're controlling the big drone swarm, and it's kind of cool. And they'll fly this swarm at a tree and it'll split around the tree and come back together again. It's like, wow. How do you actually do that? Because to control these things, you are needing to do a global operation across all the robots, and it's basically linear algebra that you're doing across the entire thing to be able to say what the robots do. And when we looked under the hood of what was happening there, the mathematics of the system matched what we needed to have done in the computing world. And so we could take these principles from this controlling swarms of drones, for instance, and actually apply that to building up all the basic computing things that you're going to need to make a computing network useful, in the sense of being able to do coordinated computing, cooperative computing, if you will.
Okay, cool. That's very interesting, because you mentioned SETI at home, and I remember back in whatever 99, 2000, like you were saying, I downloaded this program, and it used all the unused computing power on my mighty Pentium 2 333 megahertz PC or something like that, and was searching for alien life. I was like, okay, yeah, sure, why not, And it was developed by our pals down the street at Berkeley, right?
That's right. And then soon after go ahead.
I'm sorry, say that again?
And then soon after that, there was gene folding at home that came out of Stanford, and they were doing the same thing, but now folding proteins, and then it kind of snowballs from there. But the kind of problems you could solve are what's known as embarrassingly parallel problems in the community, where you take your problem and you slice it up into a bunch of pieces and you send them out to every computer. But every computer never needs to talk to anybody else for problems like that. So when you're searching for those aliens, or you're doing gene folding, some Monte Carlo simulations, no computer needs to talk to anyone else. They do their thing, and if you want all their answers back, you call it all back and put it together like a puzzle.
Okay, all right.
Yeah.
You have something called the DAC protocol that you guys, is that something you guys came up with?
So when we, back to that story about the controlling the swarm of drones, right?
Right.
The mathematical principle they leveraged was what was known as distributed average consensus. And so we use this notion of consensus to do the computing underneath the hood of the network itself. So the mathematical principle has been in development for decades. I wish we could claim credit for that one. But applying it to computing and actually implementing it in the form of this API is novel. And so this is, so if we kind of go back to that SETI at home analogy, none of those computers were coupled together. So you didn't need to have a parallel programming model to do SETI at home. But now let's say you have a humongous database strewn across user data, for instance, across their devices, and you want to do machine learning or AI across those things. Maybe you need to pull some inference from all of your data that's everywhere. You need to coordinate them. You need to have it all cooperating together. And so that's where the DAC protocol comes into play. How do you actually orchestrate these computers? How do you get them to do the cooperation to give you the quantity that you're looking for across the entire network?
Okay, all right. And you kind of briefly mentioned or talked about the rest of your team. Do you want to tell us a little bit about them? There's some interesting characters, and your website's pretty interesting in terms of having this little personal tidbit about everybody, like you play the French horn, apparently. I actually had no idea what the French horn was. I had to Google it.
That's great.
So that was interesting. And then there's somebody else who likes to do some kind of dancing, or some. So tell us a little bit about the rest of your team at Hypernet.
Yeah, we're kind of a creative bunch as it is. So myself, like a little personal thing, I guess. I played the French horn in orchestras and things like that, and then I ended up. I actually do a lot of dancing as well. I perform like waltz and do swing dancing and stuff like that. So yeah, so actually like the co-founders and myself. So myself, Daniel, and Todd, we all bonded over different things in the arts before we kind of came together to create Hypernet. And so Todd, he was in his master's and PhD at the same time I was at Stanford in aerospace. His whole bread and butter is like how you actually do large-scale computations, all the applied mathematics underneath the hood. That's all Todd's brain up there itself. And Todd actually is quite musical himself. I don't know if this is on the website, but he plays electric guitar, acoustic guitar. It's pretty incredible. On that. So in the early days at Stanford, we actually had a band together. We'd play.
Oh, wow.
There and in San Francisco a little bit too. Yeah, I would sing, he'd play guitar, and we had a few other members as well. Daniel, he is the third co-founder. He was an undergrad at Stanford when we met him, and he was in CS. He ended up leaving shortly afterwards to start a solar power electronics company, and that was acquired by SunPower, and stayed on there for a bit to kind of learn how like a large-scale organization operates. So maybe the next time he does a startup, he can take it from something small to something very large. That hopefully, as we go forward with that. But yeah, so Daniel does a lot of dancing as well. He does a lot of swing dancing and salsa and stuff like that. It's pretty great. Our lead engineer, Christopher, he was Stanford at one point in electrical engineering and computer science itself, and he's our lead blockchain engineer. And he worked at NVIDIA before we came along, and we told him about the compute project, and it was quite it's like, all right, Ivan, let's go. And I'm like, all right, let's make this thing a reality. So that's Chris, and we have a few other great minds on the team too, from the business development side to the strategy side to the marketing. We all come from different backgrounds, and it's nice to kind of see how it all comes together.
You also have the co-founder of Akamai, Randall Kaplan, is one of your advisors, right? How's it been working with him?
It's been pretty amazing, like being able to get insights from someone who started like one of the largest companies from the .com era that survived.
Right.
Actually, right. Like doing that content delivery with Akamai was quite a technical project. It was a technical company. How do you actually communicate that effectively and actually get the technical side coupled with the business side and actually bring something to market that's quite technical in and of itself has been quite great to work with Randy.
Yeah. All right. Nice. And of course, Hypernet is a blockchain project. So is there a token sale that we need to know about?
There is a token with the project. Stay tuned for announcements on that one.
Okay. All right. So that's not quite out there yet. Do you have like a timeline behind that, or not yet?
So I think we do have a timeline, obviously.
Right.
Yeah, so actually in the near future we'll be announcing some pretty exciting stuff. So just join our Telegram group, sign up to our email list, and you'll be good to go for all of that there.
Nice. Okay.
Yeah.
We'll be watching. This is a very interesting project. Any final words before we wrap up? I know it's getting late over there, so any final words?
Yeah, no. So thanks again for having me on, and I'm anytime you need anything else from Hypernet, give me a call. Should be great. And the network's coming along pretty nicely. And so actually, before we end, we just released a video of our demo on our communities there. So if you want to check that out, there's a few places you can find it in our YouTube channel or also in our announcements.
Okay, and you're at hypernet.io?
Hypernetwork.io.
Hypernetwork.io. Yeah, thanks.
Yeah.
All right. Well, thank you, Ivan. It was a pleasure speaking with you. That was Ivan Ravlich, founder and CEO of Hypernet. Uh, Thanks, Ivan, and good luck to all of you guys at Hypernet.
Hey, thank you so much.